Alright, I'm starting back with the general equation and for any conic, and when A is the same as C, we have a circle. When this number and this number are the same, we have a circle. So 2x squared plus 2y squared minus 8x plus 12y plus 2 equals 0 can easily be identified as a circle by looking at the x squared coefficient and the y squared coefficient. If they're the same, then we have a circle. So it is. So now I want you to write it in standard form. This is called general form. So remember, it's x minus Hector y minus Kyle equals r squared. So that's what I want to end up with. Alright. To do that, we have to pull out some algebra. And notice all the x terms are tucked in here and the y terms here. So let's gather our x terms together. Any term with an x in it, let's put them together. So I've got this one and this one. Then I'm going to put those in parentheses and leave a space. Next, I'm going to add to it the y terms. So I see 2y squared and a 12y. Take care of that and that. Leave a space, close the parentheses, and move the 2 to the other side of the equal sign. All right, now I want to factor out a 2. If there's a common factor in the x land, you can pull it out. And if there's a common factor in the y land, you can pull it out. All right. And now to simplify things, this factor has a 2, or this term has a 2, this term has a 2, and this term has a 2. So just to simplify life, let us divide by 2. Notice when you divide a term like this, it's just involving this 2 and this 2. It doesn't also divide into these, because this 2 is actually belongs to all the terms behind it. So when we go like that, we've taken care of it. And like that. And so we're left with x squared minus 4x, yeah, that's right, x squared minus 4x plus y squared plus 6y equals now minus 1. All right. Why did I waste all this paper right here, leaving this space? Here, we are going to complete the square. All right, to complete the square, you're going to add a special number here. And that number will also be added over here. So the equation overall is unchanged. So I'm going to add a special number. It's always half of the x coefficient squared. So here's the x coefficient. We're going to take half of it and get 2 and square it. We get 4. That's the special number we're going to add to x land. What will be the special number over in y land? Follow the same pattern. Complete the square by doing half of the x of also x, and this time the y coefficient squared. Half of 6 is 3. 3 squared, 9. Now I can't just go in and add a 4 and a 9 without adjusting. So I'm going to add a 4 and a 9 over here as well. So why did I add this special number and this special number? Because now I have a perfect square. I think Miss Ng had you memorize some of those perfect squares. So that means I can take 3 terms and write them as 2 terms squared. what will they be? Well, it's always going to be the square root of that, this sign, and the square root of that. And check it out. It does, oops, you can't see. The square root of this sign, and the square root of that. Is that equal to that? Is x minus 2 times x minus 2 equal to x squared minus 4x plus 4? If you do all the hard labor, you will see that it is. All right, let's find the perfect square we created over here. We have the square root of that, this sign, and the square root of that. And y plus 3 times y plus 3 does equal that. Over on this side, it looks like we have a 12. All right, we are now in standard form. Let us graph it. So HK, Hector and Kyle, remember grab the opposite signs. So let me give myself a coordinate plane first. I'm getting too excited here. All right, let us recognize that the center, which is HK, is going to be 2 minus 3. HK. Opposite sign, opposite sign. So go over 2 and down 3. There's the center. And what is the radius? Well, if you recall, in standard form, r squared is 12. So we want the square root of 12 to be r. So this is r squared. R is square root of 12, which is somewhere between the number 3 and 4. So I'll graph it about right there. 3 or 4 away from the center gives me a good picture of what this looks like. So I'll make one of my radii and one of my radii, and call it square root of 12, which can be reduced. So I don't want to be crude or anything. Come back here. Square root of 12 is 2 square roots of 3. So always reduce when you can. All right, that's it for your introduction to conic sections. And I'm hoping and thinking that you have seen some of this before. All right, that's it. Have a good rest of your weekend, whatever's left. Until class, goodbye.